Welcome back, everyone. Today we're taking a deep dive into something I bet you see every single day. Light. It's how you see your toys, how you read your books, and even how you know the sun is shining.
That's right. Light might seem simple, but it's actually a really fascinating topic that has puzzled scientists and thinkers for, well, for centuries, really.
We're going to travel back in time to see how people first started to study light, and then we'll explore how understanding light helps us understand everything from the stars in the sky to the colors of your favorite crayons.
A grand journey through the science of light.
Exactly. So, to start our exploration, we have to start with something pretty basic. Light is a form of energy.
Precisely. Just like the energy that powers your toys, light has energy that allows it to travel, and it travels incredibly fast. Imagine this. Light can circle the entire Earth 7.5 times in a single second.
7.5 times around the whole world in just 1 second. Whoa, that's amazing. That's way faster than any car or airplane.
No wonder when you turn on a light switch, it seems like the light appears instantly. Indeed. But here's where things get even more interesting. Light doesn't just travel in straight lines, like a car on a road. It travels in waves, much like the waves you might see rippling across a pond.
So light travels in waves. Are those waves big like the waves at the beach?
Not quite. Light waves are incredibly tiny, much too small for our eyes to see. These waves have peaks and troughs, just like waves on the ocean. And the distance between these peaks is called the wavelength. It's this wave-like nature of light that leads to many of its fascinating properties.
Like what?
Well, consider the vibrant colors we see all around us. Did you know that different colors are actually different types of light waves?
Really? So the colors we see are just different types of light.
Exactly. Some light waves are longer, like those that create the color red, while others are shorter, like those that create the color blue. It's these different lengths of the waves that determine the colors we see.
That's pretty cool. So it's all about these tiny waves, and the different lengths of these waves are what makes all the colors.
Exactly. It's like music where different notes are created by sound waves of varying length. The different lengths of light waves create different colors, just like the different lengths of sound waves create different notes.
I get it. So longer light waves make red, shorter light waves make blue. It's like a secret code of colors hidden in the light.
That's one way to put it. Speaking of codes, let's talk about a really smart scientist named Sir Isaac Newton. He he figured out some of the biggest mysteries about light hundreds of years ago.
Oh, I've heard of him. Didn't Sir Isaac Newton figure out gravity when an apple fell on his head?
That's the story. But Newton also made really important discoveries about light. He found that white light, like the light we see from the sun, isn't just one thing. It's actually a mix of all the colors of the rainbow.
All the colors of the rainbow mixed together make white light. How did he figure that out?
Well, through an experiment, a really clever one, using a special three-sided piece of glass called a prism, Newton shined a beam of white sunlight through the prism, and and he watched in amazement as the light came out the other side, separated into a bunch of colors, just like a rainbow.
So the white light went into the prism and a rainbow came out.
Exactly. The prism bent the different colors of light by slightly different amounts, causing them to spread out and become visible. This bending of light, called refraction, was key to Newton's discovery.
Wow, that's really cool. So Newton showed us that white light is actually a mix of all the colors of the rainbow, and this prism thing separated those colors so he could see them.
That's right. Newton's experiments revealed that light is full of amazing secrets just waiting for us to uncover them. But you know what? People have been fascinated by light way before Newton. Long ago, ancient civilizations had their own unique ways of understanding and thinking about light.
Oh, really? What did they think about light back then?
For ancient cultures, the sun was the most powerful source of light. It banished the darkness and brought warmth to the world. And since they didn't have the same scientific tools we have today, they explained the sun and its light through stories and myths.
Like stories about gods and goddesses?
Exactly. These myths showed how much they admired and respected the sun. For them, the sun was a symbol of power and even a source of life itself. They knew how important it was even without understanding all the science behind it.
That's pretty cool. So while they didn't know about things like wavelengths and prisms, they still understood how important light, and especially sunlight, was to them. It's like they were trying to solve the mystery of light using stories.
Precisely. It reminds us that our quest to learn about light and really the whole universe is a journey that has gone on for a really, really long time. It's a journey that is still going on today, and it's driven by our natural human curiosity and our desire to understand the world around us.
And speaking of our desire to understand the world, it seems like light plays a big role in how we learn about things.
Absolutely. Light is more than just something we see. It's a tool, really, that allows us to experience and observe the world, and that's where all knowledge starts.
So light isn't just about seeing, it's about understanding.
That's right. It's the key that unlocks all the secrets of the universe, from the tiniest little particles to the biggest stars out there.
Wow. So light is much more than just something that helps us see. It's a big part of how we learn and understand everything around us.
Exactly. And who knows, maybe someday you'll be the scientist who unlocks the next big secret about light.
It's awesome to think that something we see every day, something as simple as light, is actually so complicated and so important to our lives.
You know what, it really is. And there's still so much more to explore. Are you ready to dive even deeper into the world of light?
You bet I am. We were just talking about how ancient people used stories and myths to understand the sun. Now, we use science and these big, powerful tools called telescopes to learn about the sun and all the other stars out there.
That's right. Today, we have a whole field of science dedicated to studying the stars and the universe. It's called astronomy. And you know what's really cool? Astronomers use light to help them figure out all the secrets of space.
Wait, so how do they use light to study stars? It's not like they can travel to a star and just, take some pieces of it to study, can they?
Of course not. Stars are unbelievably far away, but luckily, light travels across huge distances carrying information about where it came from. It's like starlight is a messenger bringing us secrets from really far away stars right here to Earth.
So it's like each little beam of starlight is a tiny package filled with information about the star it came from.
You could say that. Astronomers use big, powerful telescopes to capture that starlight and then study what it's made of. That tells them a lot about the stars.
What kind of things can they see in starlight? Can they tell what a star is made of just by looking at its light?
That's exactly what they do. Remember how we talked about different colors of light having different wavelengths? Well, by studying the specific colors in starlight, astronomers can actually figure out what a star is made of.
Wow, that's pretty amazing. So it's like starlight has a secret code that tells us about the star itself.
So if a star had a lot of red light in it, would that mean it's made of something different than a star with lots of blue light?
Exactly. You see, each element, like the oxygen we breathe or the iron in your toys, emits a unique pattern of colors when it's heated up. By analyzing the colors in starlight, astronomers can identify which elements are present in the star. It's like figuring out its fingerprint.
So it's like starlight is a giant cosmic fingerprint, and astronomers are like space detectives using those fingerprints to solve the mysteries of the stars.
That's a great way to think about it. And there's even more to it. By measuring how bright a star appears from Earth and knowing how far away it is, astronomers can calculate its actual brightness. That tells us about its size and how much energy it's giving off. Hold on, are you telling me that astronomers can figure out how big and bright a star really is just by studying the light that reaches us here on Earth?
Yes, it's pretty remarkable. It's like being able to tell the size and power of a lighthouse that's far, far away just by looking at how bright its beam is.
Whoa, that's incredible. So light isn't just something that helps us see. It's this powerful tool that lets astronomers explore the universe and learn about all these distant stars.
That's exactly right. And to help them do this, scientists have developed some pretty amazing instruments to study light in even more detail. One of them is called a spectroscope.
A spectroscope, what's that? Does it make the starlight brighter so they can see it better?
Not quite. A spectroscope takes the light from something like a star and spreads it out into all its individual colors, kind of like creating a spectrum.
Like a rainbow, but more, I don't know, scientific.
Yeah. Think of it like a super-powered rainbow maker. The spectroscope shows us not only the colors we see with our eyes, but also all the specific wavelengths of light. That gives us much more detailed information about where the light is coming from.
So if you point a spectroscope at a star, you can see what it's made of.
You got it. It's like a fingerprint for the star, showing its unique makeup. By analyzing the lines and patterns in a star's spectrum, astronomers can learn its temperature, how dense it is, and even how it's moving.
That's so cool. It's like a whole other language, but instead of words, it's all about colors and wavelengths. That's a really neat way to study the universe.
It is a language in a way, a language of light that tells us all the hidden secrets of the universe. And understanding this language is the key to unlocking all the mysteries of outer space.
It's like learning a new language, But instead of words and sentences, it's colors and wavelengths.
Yeah.
That's awesome.
It is. And speaking of studying the universe, there's one more amazing thing about light that I think you'll really like. It's something that connects the sun and the earth in a spectacular way. Have you ever seen pictures of the aurora borealis or the northern lights?
Oh, yeah. I've seen pictures of them in books. They look like beautiful ribbons of colored light dancing in the sky. How are those made? Is it magic?
Well, it might look like magic, but it's actually science. The northern lights are an incredible display of light created by charged particles from the sun interacting with the Earth's magnetic field.
Charged particles from the sun. What does that mean?
Well, the sun is always releasing a stream of these tiny charged particles. It's kind of like a solar wind that blows through space. When this solar wind reaches Earth, it runs into our planet's magnetic field, which is sort of like an invisible shield all around us.
So it's like the Earth is wearing a giant magnetic helmet to protect us from this solar wind.
I like that, yeah. That's a great way to think about it. Now, when these charged particles from the sun hit the Earth's magnetic field, they get directed toward the poles, both north and south.
Oh, so that's why we see the northern lights up near the North Pole. But how do those particles make all those amazing colors?
Now, this is where it gets even more interesting. Those charged particles from the sun crash into atoms in the Earth's upper atmosphere, which energizes them and makes them release energy in the form of light.
So it's like the particles from the sun are giving a little boost of energy to the atoms in our atmosphere, and then those atoms light up.
That's it. And the different colors we see in the aurora, the greens and blues and reds, depend on which types of atoms are being energized. For example, the most common color, green, is made when oxygen atoms are energized.
Wow, so the northern lights are like this giant light show in the sky, all powered by the sun and created by these tiny particles from the sun hitting our atmosphere. It's like the sun is painting the sky with light.
That's a really beautiful way to put it. It reminds us that light isn't just something we see here on Earth. It's a fundamental force that connects us to the sun and the rest of the universe.
It's amazing to think that something as simple as light can do all these things, from letting us see, to helping astronomers study stars, to even creating those amazing lights in the sky.
It's true. And that's really just the beginning. There's still so much to learn and discover about light. Want to dive into some of the more surprising, even tricky parts of how light works.
Tricky parts of light. That sounds interesting. I thought we had covered all the basics already. What else is there to know about light?
Well, we talked about how light travels, how it creates colors, and how those astronomers use it to study stars. But, sometimes light can be a little sneaky. It can play tricks on our eyes and make us see things that aren't quite what they seem.
Light playing tricks on us. You mean like a magic show or something?
Exactly. It's like nature is putting on this big illusion show, and it uses light to create some really cool effects.
Have you ever noticed how a straw in a glass of water looks broken, even though you know it's a perfectly straight straw?
Oh yeah, I've seen that. It looks like the straw is bent right where it goes into the water. Why does that happen? Is it some kind of magic trick?
No magic, just science. It's a phenomenon called refraction. When light travels from one material to another, like from the air into water, it changes direction. It bends as it crosses that boundary between the air and the water.
So the light bends when it goes from the air into the water.
Yep. And that bending of the light, that refraction, makes the straw look like it's in a different spot right where it enters the water, creating that illusion of a broken straw.
Wow, so it's not really broken, it's just the light playing tricks on our eyes because it bends when it goes from the air into the water. So what other tricks can light do? What other illusions can it create? Well, think about one of nature's most amazing shows, a rainbow. It looks like a big arch of colors painted across the sky. But a rainbow isn't a real object like a cloud or a mountain. It's an optical illusion created by sunlight and raindrops.
A rainbow is an illusion. But it looks so real. How does sunlight create a rainbow if it's just an illusion?
It's a pretty cool process. When sunlight enters a raindrop, it gets refracted or bent and also reflected or bounced back inside that raindrop. This bending and bouncing separates all the different colors of light that make up the white sunlight, spreading them out to create that colorful arc that we see as a rainbow.
So the raindrops act like tiny little prisms, splitting the sunlight into all the colors of the rainbow.
That's exactly it. Each raindrop is like a mini prism, refracting and reflecting the light to make this amazing display of color. And because there are just so many raindrops in the air when it rains, we see this big, colorful arch across the sky.
That's amazing. So rainbows aren't just pretty. They're a really cool example of how light can interact with water to make these really neat illusions.
Precisely.
Yeah.
And there's another illusion created by light that you might have seen. Have you ever seen what looks like a puddle of water on a hot road, but then when you get closer, it disappears?
Oh, yeah. I thought it was real water, but when I got closer, it was gone. It was really confusing.
Well, that's called a mirage. It's another one of light's tricks. And it's caused, by the way, that hot air near the surface of the road bends light. The light from the sky gets refracted by this hot air, and that makes it look like there's a reflective surface, like water, on the road. But when you get closer, the angle of the light changes, and poof, the illusion disappears.
So it's all about how the light is bending. Light seems to be really good at bending and making us see things that aren't really there.
You got it. And understanding how light acts helps us to explain these illusions and really appreciate how nature works in such amazing ways. From the bending of light and water to the way colors separate in a rainbow, light is full of surprises.
Wow, it's amazing to think that something we do so easily, like seeing, is based on really complex and fascinating science. Who knew that light could be such a trickster?
It's these very tricks and illusions that make studying light so much fun. It's a field where physics and chemistry and even art all come together to show us just how beautiful and awesome the natural world is.
So light isn't just about what we see. It's about how we see and understand the world all around us. It's about exploring the science behind everyday things and uncovering all the secrets that nature shows us through light. It's been a really fun journey exploring the world of light.
It really has. From its incredible speed to its wave-like nature, its ability to make all the colors we see, to its role in astronomy and how we understand the universe, light is amazing. It has fascinated people for centuries. And as we keep studying and exploring, who knows what other wonders of light we'll discover in the future.
So keep looking at the world with curious eyes and never stop asking questions about what you see. Until next time, keep exploring.